You're recording.
Thank you. Okay, so 83. We are looking at product of rational expressions. Product means what? Multiply. So we are multiplying rational expressions, multiplying fractions. So a little different than adding and subtracting because we do not need common denominators. So we don't have to worry about common denominators. Here are some steps. Step 1. Yes?
Okay, so I know that product stands for multiplication, but wouldn't it make more sense if it stood for like equal? Because you do things to get a product, so the product would be the equal outcome, right?
Sure. Yes, I see what you're saying, but yes, that's fine. Yes. Product is the answer of a multiplication problem. So yeah, so yes. That's fine. So step 1, what I like doing first is I like cross-reducing. And we can cross-reduce first with multiplication because you can only reduce things when you're multiplying on the top and bottom. So if you had two things added or subtracted, you can't cross off right off the bat. You have to factor and then cross off. But when you're multiplying, since everything's being multiplied, you can cross-reduce. I don't know why I put cross-reducing. Just cross-reduce first. So the easiest thing is to cross-reduce first. And then step 2, how do I multiply fractions together? No, it's not a proportion. If I had 2/3 times 5/7, like a normal fraction you did in middle school. Do what?
2 times 5 is 10.
10 over 21. You do not cross multiply, you just multiply across the top and across the bottom. Cross multiply is when you're dealing with proportions. This is not a proportion. Proportion is two fractions equal. When you're just multiplying fractions, you do not need common denominators. You multiply across the top and then multiply across the bottom. So you're going to reduce first and then multiply across top and bottom. So it's a little less complicated than adding and subtracting. You do not need common denominators. You're going to cross-reduce first and then multiply across the top and the bottom. And then step 3, you may simplify a little more, possibly, but we'll look at some examples. Sometimes you won't. The cross-reducing at the beginning kind of helps make it easier, have smaller numbers when you multiply.
I think you mean multiply instead of multiple.
Thank you.
You're welcome, says Cal.
Thank you, Callie. Okay, let's look at a couple examples. Let's look at one like this. Just kidding. 5 n cubed over 10 times 10 over 7n. Okay. We are multiplying, because I have the big dot in the middle, we're multiplying rational expressions, multiplying fractions with variables. So what I like doing first is cross-reducing. It doesn't matter which fraction. If it's on the top and bottom, doesn't matter which fraction, you can cross-reduce. So what things can I cross-reduce? Tens cancel out. I have n cubed and I have an n. N is gone. This n cubed becomes n squared. And that's what I mean by cross-reduce. Since we are multiplying, we can cross-reduce at the beginning, even if they're on different fractions, as long as the top, and if one's top, one's bottom, you can cross-reduce. And that's going to help when you do step 2 and you have to multiply across the top and bottom. When I multiply across the top, I'm just going to have what? When I multiply across the bottom? 7. Can I reduce 5n squared over 7 anymore? No, so that's my answer. Normally you're not going to have a ton to simplify at the end. That's kind of what cross-reducing does first. But you may. It just kind of depends. Any questions on that? Okay, let's look at another example. One like this. What if I have x minus 2 times x plus 5 all over x plus 1 times x plus 6 times x plus 1 over x plus 8 times x plus 5. This looks complicated, but I'm multiplying two fractional to rational expressions. What's nice that I notice already about these fractions? They're already what? Which means they're already factored. They are written as things times each other. So x minus 2 times x plus 5. So they are already factored, which makes it nicer when I look at cross-reducing, because I already see things, binomials that will cancel out. So since I'm multiplying, you can only cross-reduce first when you're multiplying. What things can I cross off? X plus 5, x plus 5. Doesn't matter what fraction, as long as one is in the numerator, one is in the denominator. X plus 1, x plus 1. So as I look at writing my answer, we multiply the top two together. Now, you don't need to actually FOIL. You can just write it as x plus 2 times x plus 6. If they're already factored like this, you can just leave them factored. And then on the bottom, I'm going to have a what? X plus 8. And that's your answer. Okay. So sometimes if they're already factored, you just cross out the binomials that are separated. They're all being multiplied, so you can cross them out. Any questions on that? Yeah, we're going to do a couple more. Let's look at some that are not factored. Let's look at a couple that are not factored first. So let's say I have x squared minus 2x minus 8 when I have space over x minus 4 times 1 over 9x minus 90. Okay? That's just a 1 on the second one. So this is multiplying rational expressions. Now, I can't start chopping, like I can't take an x and an x because they're separated with subtraction. So I have to factor first, so they're separated by multiplication, and then I can start cross-reducing, okay? So if you need to factor first, factor first. Maybe I should have put that up there before step 1. So if I go back up to the top, I'll put a little asterisk. You may need to factor if possible. You may need to factor first and then cross-reduce. Okay, as I look, let's look at, there's 4, top left, top right, bottom right. So x squared minus 2x minus 8, how will that factor? Okay, and yep, it's a trinomial. There's no GCF. It's a trinomial with a 1 in front, 2 parentheses with x's, and then 2 numbers that multiply to give me negative 8 and add to give me negative 2, negative 4 and 2. Over x minus 4, can't factor, so it stays x minus 4, times 1, doesn't factor. How can the bottom factor? Take out a 9, which will leave me with yep. Okay. So factor at numerator and denominators for everyone first. Now go through and cross-reduce. What things will cross-reduce? Yeah, x minus 4. Anything else? Nope. So then you just leave it. Multiply your top. X plus 2 times 1 is just x plus 2. On the bottom, I'm going to have a 9 times x minus 10. You can distribute if you want to on the bottom. You don't need to, but be your answer. Okay, any questions on that? Okay.
51 through 69?
I want to do one more with you. Let's look at one like let's look at one like this. Let's look at one like this. 1 over x plus 9 times negative x squared minus 2x plus 63 over x plus 10. Okay, so now let's go through, make sure everything is factored first before we look at cross-reducing. 1 doesn't factor. X plus 9 doesn't factor. This numerator in the top right numerator for the right fraction, negative x squared minus 2x plus 63, does it factor? It does. However, I do not have a 1 in front. This is a trinomial, but I need a positive 1 in front. So what can I do in order to get a positive 1 in front of x squared? I can't just multiply random things, but I can do what? That'll switch that. Do what?
Can you times it by a negative?
We're gonna kind of do that, but I can't just. I have to. How can I represent multiplying by a negative? I don't know if that's the right way to word it. Right. I don't want to. I can't just randomly distribute one. Was it?
What do you want us to do?
No, I want you to think about it. Is what I want you to do. I'm not just going to give you the answer. What can I do that will change these signs?
Run a negative.
You can run a negative through, but I have to keep it the same.
Run the bottom through a negative also.
Okay, you could do that, but then that's going to make this negative x minus 10. That's going to change the bottom. What can I factor out of the top? Negative 1. Factor a negative 1 out. Now, so we're not really multiplying it. We're factoring out a negative 1. That will change. Negative 1 times what gives me negative x squared? Yep. Negative 1 times what gives me negative 2x? Positive 2x. And then negative 1 times what gives me 63? Negative 63. So if you notice that you do not have a positive 1, you just have a negative 1 in front of x squared, factor out the negative 1 first. Then, let's try to factor. So times negative 1. Now I have a trinomial with a 1 in front, so 2 parentheses. X minus 7, x plus 9. They multiply to give you negative 63, add to give you positive 2 over x plus 10. Okay? Factor, cross-reduce. X plus 9, x plus 9. Anything else cross-reduce? So I have... nope, because they're separated by subtraction and addition. So I have negative 1 times x minus 7 over x plus 10. You can distribute that negative 1 back through negative x plus 7 if you want to. Doesn't really matter. But so there will be 1 on the homework where you notice you have a negative in front of x squared. So factor out a negative 1 and then factor from there. Okay? Any questions on that? Yeah, I'm okay with giving you time tomorrow to finish up the homework. So you have the rest of the packet, 51 through 69, which is a decent chunk. So I'm okay with giving you tomorrow as kind of a finish homework, makeup test, and then the test will be Friday. So we're good and ready for test Friday, okay? So we're done with the notes. We're done with notes for Unit 1. So the rest of the time, get working on what you need to work on the packet. You'll have time tomorrow to work on the packet. So use your time today. Do what? Yeah.
Ow. Anger my leg.